Now that we've looked at how to describe scatter plots, the relationship that we see, let's look at what could go wrong or how scatter plots can be misused or misleading. So a statistics teacher in Gotham makes a graph comparing times when Bruce Wayne goes on long vacations with times when Batman gets beaten up really badly. So this would be a strong, positive, pretty linear relationship. And we would describe it with the following sentence. As the number of vacations Bruce Wayne takes increases, the number of times Batman gets beaten up tends to increase as well. So the statistics students in Gotham looked at that and said, aha, Bruce Wayne goes on vacation just so he can go beat Batman up. Which if you know much about Batman, you know that isn't quite the whole story, but this is a common error that people make. Just because there's a strong linear relationship between two variables does not mean that there's a cause and effect. So just because you have a correlation does not mean that we're going to get causation out of that. There could be lots of reasons for the relationship we're seeing, and some of them are cause and effect, some of them are not. So perhaps Bruce Wayne has insider knowledge when Batman might get hurt, and so he goes on vacation just to avoid the violence and the dangerous situations. He just doesn't want any part of it. Or maybe Batman is friends with Bruce Wayne and knows that he wants to avoid these things, so he sends him on vacation anytime he thinks a dangerous situation is coming up. Or there could be no relationship at all. Both variables could be increasing for that has nothing to do with each other, or there could be something else going on. In this case, we do know that Bruce Wayne is Batman, and so that is really what's driving that relationship that we see there. All right, so let's look at some examples that are from the real world. This next one showed up in my Facebook feed. It was a migraine ad. And the first person in the comments wrote, the recent uptick in these ads leads me to one conclusion: COVID side effects are kicking in. So their claim is that the increase in migraine ads they see on Facebook is due to lots of people having gotten COVID and thinking that headaches are perhaps a long-term side effect of COVID. Okay. There's lots of reasons that those ads could be increasing. Even just simple things that you're Googling can trigger more of those ads. So you'll see this a lot. People will attribute cause and effect to something that really you don't have any sort of strong relationship there. You're also going to see this show up when it comes to legislation. So it's really something you want to consider whether that's a correlation or whether it's cause and effect. So for example, there's been a lot of discussion about banning flavored tobacco in the hopes of getting teens to not smoke as much or not start smoking. In order for this legislation to be successful, there has to be some element of cause and effect between flavored tobacco and teens that are smoking it. We would need to look at the specifics of how the data was collected and the research methodology to see if they have support for the claim. If there is not a cause and effect relationship, then what you did was you just passed really expensive legislation that's not going to be effective and not going to tackle the problem that you're trying to address. And so we'll look a little bit later this semester at how to determine whether you get cause and effect out of your research. But another way that we could address that, or at least try to get at that, is we could look at places that have passed this. So Santa Ana City Council did pass a ban on flavored tobacco. And so we could look and see if their rates of teen smoking have dropped off. Okay, that doesn't solidify cause and effect, but it gets us a lot closer to it. All right, whether someone is trying to claim cause and effect, it's something that's silly and easily debunked, or in the case of legislation, it's something that really could be true. We need to look into it further. One thing you need to watch out for in statistics is something called a lurking variable. Okay, so we're going to introduce a new variable here. We're going to do that with this example. Does eating ice cream cause drowning deaths? So you'll see our explanatory or predictor variable on the x-axis is the amount of ice cream that's being produced. And on the y-axis, we have the response variable. That's the number of people that drowned. So I look at this and I see a fairly moderately strong, positive, fairly linear relationship. And the sentence I would use to describe that is, as ice cream sales increase, drowning deaths tend to increase. That sounds awful. I don't want anybody to die of drowning. So I think that I'm going to stop eating ice cream and I'm going to lobby the politicians to put a cap on the amount of ice cream. Because, I mean, if we could just not eat as much ice cream, think of all the people we could save. Is anybody on board for signing my legislation? Yeah, probably not. There's something else going on here, and that something else is called a lurking variable. So a lurking variable is a hidden variable. It's a variable that's neither X or Y. So it's not your explanatory or predictor variable, and it's not your response variable on the Y-axis. But it impacts both of those variables, and it accounts for the relationship between them. So when I look at this, what's really going on is the time of year that it's summer and the temperature is increasing. So the lurking variable here is going to be temperature, and then the way that it affects both X and Y. So for X, as temperature increases, more people eat ice cream. So we have to ramp up ice cream production, and that's why that increases. And then for the response variable on the Y-axis, as temperature increases, people are hot, which means more people go swimming, and then the more people in the water, the more potential there is for people to drown. Okay, so it's not really that ice cream is causing people to drown. There's this variable of the temperature underneath that's really driving the relationship we see. So scatter plots and correlation coefficients never prove cause and effect or causation. So that's where you get that statement, correlation does not equal causation. Right, now that we've seen an example of a lurking variable and kind of broke it down, see if you can figure out the lurking variable in the next two situations. All right, so this one, the little boy is saying, I wish they would stop turning on the fasten seatbelt sign. It makes everything on the airplane bumpy. So take a second, see if you can figure out that lurking variable. All right, so the lurking variable there is the air turbulence. As far as the predictor variable, as air turbulence increases, the fasten seatbelt sign is going to be turned on more times. And then as far as the Y variable or the response variable, as the air turbulence increases, the plane is going to experience more bumps and drops in that flight pattern. And so the air turbulence is really the lurking variable there. It's not because they turn on the fasten seatbelt sign that's going to cause the plane to be bumpy. Right? And this next one, studies show that there's a correlation between traffic accidents and popcorn consumption. Is this because higher consumption of popcorn causes more traffic accidents? Or is it the other way? Do traffic accidents cause people to consume more popcorn because they're sitting at home, they're recovering from this accident, and popcorn just sounded really soothing and good? What's really going on there? What's a lurking variable that could be causing both of those to increase? So a lurking variable in this situation could be the population. As the population increases, more people are going to be eating ice cream or eating popcorn. And as the population increases, there's more cars on the road, which leads to more traffic accidents in general. So population is what's really driving both of those to increase. All right, so some problems caused by lurking variables, they can falsely show a strong relationship between two variables. It can hide the actual relationship that's going on. It can cause the correlation analysis or regression analysis, and we'll look at regression in the next chapter, to mislead the researcher. They can cause bias in the results of your research, and they can invalidate your research because it can impact the entire study without you even realizing they're there. So they're definitely something you want to take a good look at.